Okay, in today's class, we're going to look at performing a regression analysis. What this is just doing the whole process of all the things that we've been doing with the data, the numerical data. So as you can see, the first thing we will do is construct a scatter plot, and then the next thing you'll do is calculate the R value, which is the strength. Then they'll ask you to determine the least squares regression line, which we did. So that means you need to use your calculator and find the A and B value and write out. Then they're going to ask us to interpret the coefficients of the least squares regression line. So when they say interpret the coefficient is the A and the B values. So essentially it's the slope and the intercept. So remember that the slope is the B value, so you might write that slope equals B value and intercept is the A value. Okay, then you're asked to make predictions. So what we're going to do is use the least squares regression line and ask to predict what we think might happen. And then they'll also ask you to determine the R squared and also interpret that, which we've seen how to do that. And then the last thing, which is a new thing we'll need to learn, is how to create a residual plot and what we use it for, because it actually tells us something, and it tells us something about whether the graph is linear or not linear. So let's go through this example here. It says life expectancy in years and birth rates with the number of births per 1,000 people have been determined for 10 countries. So if you can see, we would probably predict what we're trying to predict life expectancy. So life expectancy will be the response variable and birth rate will be the explanatory variable. So here we'll have life expectancy and here it will be birth rate. So we've done that, we've put the lists in the listen spreadsheet and we've calculated, created a scatter plot. We have then created the line of the least squares regression line and we've calculated the A and the B value here. Okay, so then what they might ask us to do is they might ask us to interpret the slope, which means interpret the B value. Now, if you have a look here, our B value is negative. So over here, I've got a template on how you can write out when you're asked to interpret. So if you're asked to interpret the slope, this is what you're going to do. Now, because of this example here, it's a negative. I'm going to use this one. So the way I would write this, I said now it's in yellow because you have to fill it in. So what was the response variable in this was life expectancy. So I'd write the life expectancy decreases because it's negative by, and I'm going to say I put the B value here, so 1.44 when now I need to put the explanatory, which is birth rate, increases by 1. Now you have to put the units, so the units for this is per 1,000. That's what they're saying. All right, if I was asked to interpret the intercept, which is the A value, I'm going to use this little expression. So the regression line intercept predicts now we have to put the RV, so in this example, life expectancy to be, and then we put 105.4 years, so because that's when the birth rate is 0. Okay, so there's how you always use these these fill in the blanks, and then you can't get it wrong. Okay, so now we've got this formula here for life expectancy, so we could use this to predict what we think the country's life expectancy would be if we knew their birth rates per 1,000. So here they're giving you an example. So what's the life expectancy of a country with a birth rate of 35? So what you're going to do is you see that we put, instead of having times birth rate, we put actually what the birth rate is here. So it was 35, and we see that the life expectancy for a country like that would be 55 years. So on average, the country with a birth rate of 35 will have a life expectancy of 55 years. So this is called predicting, when you use the equation to work out what something might happen. Okay, so then we're looking at, because we're doing an analysis of this data, so they found that the R value was a negative. So we saw that life expectancy and birth rate, the R was negative, and we saw that the scatter plot went down. So you can see as the birth rates get higher, the life expectancy goes down, because what that means is there's a more pressure on, say, resources, and there's higher population. So when that happens, often life expectancy goes down. So if you think of highly populated countries, say like India, the life expectancy isn't as high as, say, in Australia, and that's generally because there's less people, we get more healthcare and things. These are things we don't need to know, but that's why we would expect that. So they then work out the R squared value, and remember we can change the R squared to a percentage. So it ended up being 0.651. So we changed it to 65%, and then I can use my R squared blurb. It tells us that 65.1% of the variation in, and remember you have to fill in this and write the response variable, can be explained by the variation in birth rates. This is where you put your EV. So if you've got, because it's a high, that's pretty high, so we can say, yeah, that it is a fairly, birth rate is having, the change in birth rate is affecting the life expectancy. Okay, so then before, the last little thing we're going to look at is interpolation and extrapolation. So if you had a look at it before, we had the scatter plot, and they asked us to predict a country with a birth rate of 35. Okay, so they asked us to predict a birth rate of 35. So what we would have found is we found this line here. We found this value here, which we said was something like 55. So, it was 55 when you use the prediction. Now, with the country that actually had a birth rate of 35, which say it was this one here, they actually had a birth rate. What really happened was, I'm going to say, make it up, it was a birth rate of, 45. Okay, so the residual, if I was working out a residual for this data, it would be actual minus predicted. So the predicted is the line, which was 55, and the actual was what actually happened, which was 45. So this one is a negative 10 residual, which makes sense, it's below the line. Okay, now what happens is, because I got asked to predict, so because I predicted 35, I was predicting 35 here. Can you see with all my dots are ranging between 25 and say up to here. When you predict within your data, so because 35, I had some predictions of lower and here and 45. When you predict between those two within your data, it's called interpolation. So our 35 prediction, when we found it, was interpolation. If I'm asked, I might get asked to predict, what if I got asked to predict a country that had a birth rate of 5, say down here, so I'd put into the formula, so life expectancy equaled, it was 105 minus 1.44 times 5. When I'm doing that, I'm not predicting within where I've recorded data. So you can see my dots are all in here. This is outside where I've collected data. So that's called extrapolation. So that one would be an extrapolation. If I predicted up here at, say, a country with a birth rate of 90, that's also extra. It's outside the data source. Okay, so we're going to now look at our residual plot. And it's really important, and it's why I've popped it in the yellow, is when you're doing the least squares, when you're creating a least squares regression line, you are assuming that the graph is following a straight line or a linear pattern. So that's the assumption you're making when you're doing these. So you're assuming that it's linear. So that's why it says the key assumption made when calculating the least squares regression line is that it is linear. So you're asking the calculator to create this straight line pattern. So that means you're making an assumption that you think it is following it. So we have a test to see if it really is following a linear pattern, and that's called the residual plot. So the residual plot is when you plot all the little residual values. So if you have a look here, all these distances, sorry, I'll do it like they've done. All these distances are the residuals. And what the calculator does is it calculates all of those residual values and creates a residual plot. So what they do, so if you have your axes here, you still have all your x values along here. So I'm just going to say like to 26, and then you actually put what its residual was. So what I'm looking at is this dot here. It looked like it was roughly 26. It was 60, but the line predicted 67 or something. So it has a negative residual. So this one would be, so say you have 0 line there, it has a -7, so its dot would be here. If you have, say this one here, I'm going to do this one up here, it was on 38. So say when it was 38, this one in particular had, say it was predicted 50, but it was actually 53. So it had a residual of +3. So it's like that. So you can see this is what the calculator does. It works out all those little residuals and creates this plot for you, and it's called a residual plot. So we're going to go back to this example of life expectancy. So with the birth rate, here we've got a couple more examples of calculating the residuals. So it says the country labelled A, which they've got up here, and the scatter plot has a birth rate of 34. So that's an X value, and a life expectancy, that's the Y. So that is, this 66 is the actual value. That's actually what happened. Now, if I pop that in, the 34, into the formula, we predict, this is a prediction of 56.4. So the formula predicted that. So we can work out the residual by going actual minus predicted, and we see that A has a residual of 9.6, and that makes sense because it's above the line, it'll be a positive one. Then they wanted us to do country B. So country B here was at 30, its X was at 34. And so if you type that into the thing, it's still the same, it still predicts because it's the same country. You can see there's two countries, both at a birth rate of 34. But this one, its actual life expectancy was 49. So when you work out the predicted, it's a negative, and you can see that's why it's down below the line. So there's two other examples. So they would be on our residual. So say we had country, so this would be at 34. We'd have country A up here, A would have a positive residual, and B would be down here with a negative residual. Okay, so now we're going to look at how to do the residual plot. So once you've created a scatter plot on your calculator, so I'll do this in class and show you, but we've got a scatter plot. Well, to get the residual plot, you have to put the regression line on your scatter plot. So the way you get that is you go menu, analyze, and show regression, least squares regression, regression, and you'll get this line on your scatter plot. Only once you've done that, then you'll have the ability to get the residual plot. And then once again, you press instructions are here. You press menu, analyze, and then you can get residuals. You won't be able to get that residual unless you've done this step up here. And then show residual plot. And what it actually does is split the screen. So this is the original scatter plot. And this is the residual plot. So this is like they've done this, what we've done here. This is the residual. And what we look for in the residual, if there is no clear pattern. So here's another example of, this is the example of the residual for our life expectancy and birth rate. See, if you look here, the pattern of these dots, it's all just random. We can't see any pattern in there. So if there is no clear pattern, this confirms our original assumption that it's linear. So if there's no pattern in the residual plot, it confirms it is linear. But if you look up here on this example on the calculator here, I would probably say that this has a pattern. So this one, because the residual shows a pattern, so they're not really randomly scattered, it's sort of showing a thing. This indicates the data is not linear. So that's an example of a not linear. This one is an example of a linear. Okay, so we've got a few exam questions we're going to do. The relative humidity at 9 a.m. and 3 p.m. on 14 days in November is shown in the table below. The least squares line is fitted to the data in the aim of predicting relative humidity at 3 p.m. Whatever they're predicting, that is your response variable. So this is definitely y, and this is my response variable. And from the relative humidity at 9 a.m. So 9 a.m. is x, and explanatory variable. So name the explanatory variable, so we know that's 9 a.m. Okay, it says determine the values of the intercept, so this is the a value, and the slope of the least squares regression line. So you pop this data in and get your a and b value, which we have done that. So I've popped them in, and I'm getting my a value and my b value. Now I'm going to be really careful, and look, it says 3 decimal places. You need to be really careful because sometimes they're going to say significant figures and sometimes they're going to say decimal places. So they're saying 3 decimal places, so I'm going to go negative 1.262 because that would round it up. And the b value is 0.765 because that 9 would round the 4 up. Okay, and it also asked me to determine the correlation coefficient for this data, and it's just actually missing on here to 3 decimal places, but it would have been under here. So we'll work that out. So you would have seen that it was 0.871 for the R value. So correlation coefficient is R value. With another residual plot, I've used this data. Okay, so just to show you, sorry, I'm going to show you a residual plot using the data from the other page. So you can see here's the 9 a.m. humidity and here's the 3 p.m. humidity. Now this is the original scatter plot. So this is the scatter plot, and I've put the least squares regression line on it by using menu analyze. Okay, so when you do the least squares to get this line, you still go menu and you go analyze, and you actually pick this one for when you're getting the regression line, and you say show regression line. Once we've got that line, then we can get the residual plot. So we press menu, analyze, we go down to residuals, and it says show residual plot. So here we've got the original scatter plot, so this thing up here, done again, and we've got the residual. Now, because the residual showing random pattern here, that suggests, so the random pattern, random scatter suggests the data is linear. Or you could, another way of saying that is it supports your assumption. You're assuming that it was linear, and this supports it. Okay, so let's have a look at some more questions. We've got the scatter plot below shows the atmospheric pressure in hectopascals at 3 p.m. plotted against the atmospheric pressure at 9 a.m. for 23 days in November. So you can see here, down here is 9 a.m. and here's 3 p.m. So they're saying the 9 a.m. is your X and the 3 p.m. is your Y, or your explanatory variable and your response variable as such. A least squares line has been fitted and the equation is here. So they've given me the equation. So I know this is my A value and this is my B value. So there, when you see these, you're going to see, whenever you see interpret something and it's saying interpret the slope, I'll have a fill in the blanks for you, which I've put here. I've gone back to the notes and found it. Now, because this B value was a positive, I've picked the positive statement. So now I've got to put the response threshold. So I write the pressure 3 p.m. increases by, and I've got to put the B value in the units. So I go increases by 0.8894. Now the RV units, which is hectopascals or whatever. What's the EV? Is the pressure at 9 a.m. increases by 1 and EV unit. So the EV unit is also hectopascal. So you buy 1 hectopascal. All right. So then use the equation of the least squares to predict the atmosphere at 3 p.m. when the atmospheric pressure at 9 a.m. is 1000. So they're giving me the X value. So I'm going to write pressure at 3 p.m. and I use the formula equals 101.4 plus 0.8894 times 1025, and I'll get, and it's set to the nearest whole number, so I'm going to make sure I do that. So I got 1023 was the nearest whole number. So it says predict, and maybe should write the units. I'll just put the units there. Okay, so they're asking me now up here, in part B, which we just did, is the example extrapolation or interpolation. So if you go and let's have a look. They asked me to predict at 9 a.m. at 1025. So that's here. If you look, that's within my dots. Yeah, the dots are starting from here and going up to about there. So in anything predicting in this category along here would be interpolation. This is interpolation. If I was asked to predict outside, so say if I was asked to predict out in here, this area, that would be extrapolation. Okay, when we're not inside the dots. Sorry, so that should be outside the dots is the extrapolation. So they asked to make, so I've just copied our little notes, and it said predicting within the data range is interpolation. So this one was interpolation. Now it says determine the residual value. So what I want you to start doing when you see these questions in your exam, you write residual. That's the thing. So write the formula. So that equals actual minus predicted. Okay, so the predicted, you just work that out. So you at the 1, 2, oh no, actually it's doing another one. So it's doing 113. So you've got to predict. So you've got to use your equation again. So you go 3 p.m. would equal 11.4 plus 0.884 times 1013. So you'll get your predicted value. They're saying whole number here, so I'm just going to predict. My value was 1012 when I predicted it. So this equaled 1012. Now, the data value, so I'm trying to find the residual, so I actually need now, it's either the dot or the graph or from the table of values. So I don't have the table of values here, so I'm going to go and find the dot on the graph. So 1013 is here. So you go up here and you can see, all right, so it actually had a 1015 value. So then you do 1015 minus that. So it has a residual value of 3. That's a positive number, which is good because this one's sitting above the line. All right, then the mean and standard deviation of pressure at 9 a.m. and 3 p.m. for these 23 days are shown. So this is my X. So this is mean of X. This is my Y. So this is mean of Y and SX and SY. Use the equation of the least squares line information in table 4 to show that the correlation coefficient, so the R, for this data is this. So because they're making you use this information from this table, you need to use this formula, which I've found again for you. So we would type that in. So we know the B is the slope. So they also said to use the least squares regression line formula. So I need to get B. So B's over here. So B is 0.8894 equals R, which is what I'm trying to find, times S of Y, which is 4.1884 over S of X, which is 4.5477. And you can, it wouldn't matter, you can still write the word solve, even though they said show that it is, and go comma R. They're really showing, you're just showing you know where you got the data from, and then just write it equals 9.66. You might as well write what they told you it is and pop it in there. Now, when we've got the next question, it says what percentage of a variation, when you see percentage variation wording, they're talking about R squared. So what percentage of variation pressure is explained by the variation in that? So R squared, we're going to use the R value they got, which is 0.966, and we're going to square it, and we'll get an answer. Now it says round what percentage and round to 1 decimal place. So I'm going to say I've got this to be 0.933 and so if I change that to a percentage, it would be 93.3%. So I'm going to leave it at that. Sorry, that was 1. So, all right, so then yeah, they've just asked you to what percentage, so there's your answer there. They haven't asked you to interpret, but if you had to interpret, you have to go get the blurb. Okay, so now they've shown us the residual of this scenario. So here's the X values, the pressure at 9 p.m, and here's all their residuals. So if you look at this, the residual plot above can be used to test one of the assumptions about the nature of the association between atmospheric pressure at 3 p.m. and at 9 p.m. What is the assumption? So they're just asking you that it is linear. That's it is linear. Okay, that's always what you're assuming. The residual plot above does not support this assumption and why. If you have a look, this is not really random. Can you see that the dots are sort of follow this sort of curved line? So even if you weren't, you're a bit unsure, you might have thought, oh, that looks random to me anyway, but they're telling you that it's not. So if they said it does not support it, so just if it does not support it, that means they believe there's a pattern in there. So you just say, explain why, because the scatter shows some pattern in it, and you might say, well, not, it's not random, therefore it is nonlinear. Sorry, it's not random there, therefore it is nonlinear. All right, so that's what you would write for that. Okay, this question, the data in the table below shows the actual temperature and apparent temperature recorded in the weather station. The data will be used to investigate the association between the variables apparent temperature and actual temperature. They love to use words that are very similar. So see how apparent looks like actual visually, because they're both A's, so you need to be really careful and read. Now, if you have a look, they've given you a table of values, but the big trap here is that they've shown you the scatter plot. So you can see that apparent is on the y-axis, so it is your response variable. So just be careful, because they've actually put your y here. So that's your response variable. And the actual is your x, or your explanatory variable. So normally we see the x written first, but see, they're trying to trap you here, and they've put them around the other way. So use the scatter plot to describe the association between apparent and actual temperature in terms of strength. So strength means your R value. So you would say, I don't know, when you calculate it, it would have been down here. So let's go work out the... Okay, so the R value is 0.98. So this graph is a strong. The direction is positive, it's going up, and the form is linear. So we just say strong, positive, linear relationship. Yeah, you answered that. Determine the least squares regression line. So I popped in the data already, and remember that actual, see how I changed it around when I typed it in, I put the X first and the Y second. And then you had to fill in. Now be careful here, they are asking for two significant figures. So this is the A value. So if I look down here, two significant is -1.7, because I'm looking at the 5, that's got to go up, and there's two significant. And for the actual temperature, for the gradient, you don't start counting until you get a non-zero number. So now the 9 is, so it's 9.4. So there's the two significant figures for that one. Oh, I can't even remember now. Yep. It's asking me to interpret the intercept, so that's the A value. So you're gonna go get your A blurb because it's an interpret. We'll go get that. Okay, so I've gone and looked up my notes, and I've found where I've got the line for interpret the A. So regression line intercept predicts the RV, which was apparent temperature, to be the A value, which -1.7, when the EV, which was the actual temperature, is 0 degrees Celsius. Okay, then the next question, they're asking the coefficient of determination. So remember, that's R squared. Between the variables and temperature is 0.97. Interpret this. So you need to go get your blurb for R squared, which says it would be interpret this. So 97% of the variation in the apparent temperature, can be explained by the variation in actual temp. So you've got a little template that tells you how to fill this in, and you have to change that one, write your RV there, and you your EV in that spot, and you have to obviously tell me what the R squared is. Okay, obviously it can make it quicker if you remember them off by heart. The residual plot is obtained and it is shown. So here, I reckon this looks pretty random. So because it's got random scatter or unclear pattern, we're going to say this supports it's linear. Okay, the residual plot can be used to test an assumption about the nature of the association. What is the assumption? It is linear. So you can see the exams start to repeat themselves. And does the residual plot support this assumption? Yeah, we'll just write that in there. Yeah, the random scatter unclear pattern support it's linear. Alright. I've just put the answers here for this one. You guys can go through it.